Welcome to this video on the history of mathematics, focusing on the development and architecture of the Hindu-Arabic number system. This system, which emerged in India around 800 AD and was transmitted by the Arabs, revolutionized mathematics with its decimal place value framework and the invention of zero. The true genius of this system lies in the use of zero to handle empty powers of 10. With symbols 0 through 9, any number can be easily represented. The Hindu-Arabic algorithm is built on 4 pillars: 10 universal symbols, base 10 grouping, positional value, and additive and multiplicative logic. Pillar 1 consists of 10 distinct digits. These foundation symbols can combine to represent all possible numbers, and the term digit reflects the biological origin of counting. Pillar 2 is base 10 grouping. In this system, groups are consistently replaced by the next magnitude of 10, which allows for infinite scalability. Pillar 3 is positional value. Here, the value of a digit is strictly determined by its spatial location, ascending in magnitude from right to left. Pillar 4 covers the system's additive and multiplicative logic. The final value of a numeral is found by multiplying each place by its digit and adding the products. As an example, to understand the number 4,687, we multiply each digit by its place value, thousands, hundreds, tens, and ones, and add the results together. Number nomenclature follows a logical progression: unique names for 0 through 12, the teen suffix for 13 through 19, and standardized naming for tens and hundreds. Beyond the basic system, the Indian number system scales to astronomical heights, using unique periods to comprehend massive quantities. While the West often groups by thousands, the Indian system uses terms like lakh for 5 zeros and crore for 7 zeros. This system continues to scale to even larger magnitudes, including Arab with 9 zeros, all the way up to Padma with 15 zeros. The architecture of these periods helps us read very large numbers. For example, 1154.08 453 is read as 11 crore 54 lakh 8,453. Finally, we use a 3-2-2-2 rhythm of punctuation to separate these periods, making large numbers much easier to write and read. This slide displays how a large number is broken down into its linguistic components, mapping each digit to its corresponding place value name from crores down to ones. Here we see the mathematical expansion of that same number, demonstrating how the system functions through both multiplicative and additive methods. The relational mechanics of the system show that even a small change, like adding or subtracting one, can fundamentally shift the magnitude across the entire place value architecture. Order is central to these mechanics, allowing us to easily arrange sequences of large numbers in either ascending or descending order by comparing their positional values. From 10 simple symbols and the concept of an empty space, humanity created a universal system capable of measuring everything from daily counts to astronomical scales. This concludes our video on the architecture of the Hindu-Arabic numerical system, one of history's most enduring and vital inventions.